Okay. Now, in the same manner, we have to see the another possibilities also. But anywhere in any question, in any S-plane, if the t term is coming in the time response, a t term is coming in the impulse response, which you have to be remember that the poles are repeated. Where it is repeated, see the second term. If it is exponential, poles are repeated on the real axis. If it is a sine term, poles are repeated on the imaginary axis. Sir, negative real axis or positive real axis, don't confuse. E power positive real part means positive real axis. E power negative, e power minus means negative real axis. E power plus means positive real axis. That is the only thing you have to be identified. Now if the pole's location is like this. Now this is complex conjugate poles. These are complex conjugate poles. Now, first time in this particular problems you just observed is having both real part and imaginary part. So, whatever it may be, then this is the real part, imaginary part, then we will start the analysis same. For all the questions how you are solving, the same manner. Then, how many poles? This is one pole, this is another pole. Therefore, there are two poles, therefore, order equal to 2. Order which is equal to 2. The pole lies on the left hand side of S-plane, therefore system is stable. We can find the time constant. What is the time constant? Negative of reciprocal of real part of the dominant pole, but here it is only one pole. Therefore, this is nothing but -2, which is equal to 1 by 2, which is equal to 0.5 seconds. If you observe remaining all the previous problems, there is no imaginary part. We are saying frequency of oscillation is 0 radians per second. But this particular problem, there is imaginary part, j omega. Therefore, that imaginary part, what is the imaginary part? One is plus omega, another one is minus omega. But practically, there is no negative frequencies. Therefore, you consider the frequency of oscillation as plus omega. Therefore, j omega 4 radians per second, because in this particular problem there is a imaginary part. What is the meaning of that? The frequency of oscillation is 4 radians per second, which means that definitely the response is having some oscillations. Definitely the response is having some sine or cos term. The response is having some sinusoidal nature. That is the point we have to be identified, which means that previous all the problems there is no imaginary part, which means that the response does not having any sinusoidal oscillations. But in this particular problem, there is a imaginary part. If there is a imaginary part, which means that definitely the frequency of oscillations present. Not only that, definitely there is a sine or cos term present in the response. That you have to be identified. Therefore, now see here, that's what I am giving one simple shortcut method for any particular poles and zeros location. What is the impulse response in time domain? Now see here, the impulse response now in time domain, which is equal to some constant into what I am saying, e power real part. What is the real part? E power real part. Real part is -2 into t. Sine or cos. Don't confusion of taking a sine or cos term. Here it is not important to take whether a sine wave or a cos wave. Here important what is the frequency of oscillation. You may take sine or cos, not a problem. Now k into e power -2t into sine imaginary part. What is imaginary part? 4 sine 4t. This is the impulse response in time domain directly. This is the impulse response. This is the impulse response in time domain directly. This is the impulse response. That's what I'm saying. Previous all the problems you just observed, there is no sine or cos term. Why previous all the problems there is no sine or cos term? Because previous all the problems there is no imaginary part. But in this particular problem, there is a imaginary part. When there is a imaginary part, there is a frequency of oscillation, and definitely there is a sine or cos term. Therefore, then how to draw the response? Now see here. Now these are the two signals. One is exponential signal, another one is sine. Now I am giving one concept, then you just remember that concept. Now if you want to draw the response of this, which response you are drawing? The impulse response. But what is there in the impulse response? One signal is exponential, another signal is sine. Then what I am saying is, any signal means you take any signal, exponential or ramp or parabolic, whatever it may be, any signal multiplied with, this is important here, any signal multiplied with a sine or a cos term, any signal multiplied with a sine term or a cos term. Remember carefully, any signal multiplied with, I am not mentioning exponential, any signal multiplying with sine or cos term. Now the response is drawing like this. Now forget about the sine and cos. First you draw the response of the remaining term. Now what is the response of the remaining term? The remaining term is exponential term. Therefore exponentially decaying. Forget about this sine or cos term. Now this is exponentially decaying. Now with respect to time, draw the mirror image. Now with respect to time, now forget about the sine or cos term. The remaining term is exponentially decaying. Then with respect to time axis, draw the mirror image. With respect to time axis, draw the mirror image. Therefore, now this is sine or cos, forget about the sine or cos, exponentially decaying, and with respect to time, the mirror image is this one. And in the common area, then indicate the frequency of oscillation. What is the frequency of oscillation? In the common area, the frequency of oscillation is 4 radians per second. In the common area, the frequency of oscillation is 4 radians per second. Therefore, now this is the frequency of oscillation, which is 4 radians per second. Then if you want, you observe here. Now this response is having any oscillation or not? Yes. Then this response is having an oscillation. What is the oscillation frequency? And the oscillation frequency is 4 radians per second, which you already decided by looking the imaginary part. And yes, there is a sine term and whose frequency is same, matching. That's what I'm saying. When there is an imaginary part, there is an oscillation present in the response. Now see here, this is the response. Can I write like this? Now this is the response I named as the response is exponentially decaying. The response is exponentially decaying and decreased. Exponentially decaying and amplitudes are decreasing. The response is exponentially decaying and amplitudes are decreasing. The response is exponentially decaying and decreased amplitude of oscillation. Decreased amplitude of oscillation. The response is exponentially decaying and decreased amplitude of oscillations. Now this is the response now when the poles are complex conjugate and which lies on left hand side of S-plane. Now one more thing also we can write. Where there is an amplitudes are decreasing, where there is an amplitudes are decreasing. Decreasing amplitudes, which we are also called as damping. Decreasing the amplitude means we are called as damping. Damping means decreasing the amplitude. Therefore, we can write like this. The response is exponentially decaying. The response is exponentially decaying and damped frequency of oscillations. Damped frequency of oscillations. The response is exponentially decaying and damped. Decreasing the amplitude means damping, therefore the damped frequency of oscillations. Now, therefore, this frequency of oscillations, which we also named as this 4 radians per second, which we also called as damped frequency of oscillation. This omega we call as omega d, damped frequency of oscillation. Omega d equal to 4 radians per second. Response is exponentially decaying and decreased amplitude of oscillation. Decreasing amplitude means damping. Therefore, this is the damped frequency of oscillations. Now, omega d equal to 4 radians per second. Just take this one. Okay, this concept is also very useful throughout the syllabus. Then you just see here, any signal multiplied with a sine or cos term, any signal multiplied with a sine or cos term, then forget about this sine and cos, take the signal other than sine and cos. This is here is exponential signal, draw the exponentially decaying. Then after that, with respect to time axis, draw the mirror image. This is the mirror image. Now, in the common area, then you indicate the frequency of oscillation. In the common area, the frequency of oscillation is 4 radians per second. Okay. In the common area, the frequency of oscillation is 4 radians per second. Now, like that, we have to draw the response. Like that, we have to identify the frequency of oscillations. Now, this is the response, which is exponential decaying and decreased amplitude of oscillation. Now, this is the decreasing amplitude means damping. That's why this frequency of oscillation is called as damped frequency of oscillations. And some of you are thinking that, sir, this is a shortcut method you are taking directly, which will give the correct results or not. Sir, this is correct or not? You are saying directly k into e power real part and sine or cos into imaginary part, which is correct statement or not? Which is correct or not? Now, there is no doubt about that. That's what I am clarifying. The doubt what you are having is correct or not. Then I will solve for the lengthy method also. Then both are matching or not also we will see. For this particular problem, we will see that one, and remaining problems you can straight over take this formula if you have some confidence. Now, this is a shortcut way which we are followed. Then I just do the long method. I just do the general procedure. What is the general procedure? This is the pole location. What is the pole location? Now, one pole is -2 plus J4 and another pole is -2 minus J4. Therefore, this is the pole's location. Therefore, can I write like this? Now, the pole means denominator polynomial 1 by s plus 2 minus J4 into 1 by s plus 2 plus j4. Now you see here 1 by a plus b into a minus b. Therefore, a plus b into a minus b, a square s plus 2 whole square minus b square j4 whole square. A plus b into a minus b, a square minus b square. Therefore, which is nothing but 1 by s plus 2 whole square, j square means minus 1, minus minus plus 4 square. Now if you see here, this is nothing but 1 by s plus 2 whole square plus 4 square. Then in the numerator, if I multiplied and in the numerator if I multiplied with 4 and divided with 4, then this 4 cancel and this is equal to 1. Therefore, now can I write like this? Then this is nothing but 1 by 4 is constant into 4 by s plus 2 whole square plus 4 square. So this we can write like this. If I apply the inverse Laplace transformation, then this is the inverse Laplace transformation. 1 by 4 is constant. B by s square plus b square, which is nothing but sine bt, and in place of s, this is s plus 2, which is nothing but e power minus 2t. This is the general and standard procedure. Now for doing the general and standard procedure, now we can get this answer. In the shortcut method, what you can get the answer? Some constant, e power minus 2t, e power minus 2t, sine 4t, sine 4t. Then this is the answer you can get directly. Some constant, e power real part, sine and cos imaginary part. That is the method which you can use and you can get the answer directly. Why unnecessarily wasting of this lengthy method and lengthy calculations? Then anyway, for comparison, then some of you are asking this is correct or not. That's what I'm giving this method also. Both are matching the same, both are same answers or not. Then if these two answers are matching, then there is no need of doing this particular lengthy calculations in the questions. Then you just see the question and get the impulse response in time domain directly. Okay. For the comparison purpose, for here you can take both, but for the next time they're not required of this lengthy calculations. Straight over use that shortcut method and get the answer directly. Take down this. Now this standard procedure is not required. Now after doing this standard procedure, whatever the answer you are getting, the same answer you can find directly with this help of one single step. Now here also, just I want to do the small change here. The same problem I'm doing, but now I just repeat here. Then now see here, if I just repeated the poles here, then first we want to find these 4 parameters are important. Then after that we can find for any problem. Okay. Now how many poles? There are 4 poles. Therefore order equal to 4. Pole is lies on the left hand side, system is stable. Time constant is negative of reciprocal of real part is -2, therefore 0.5 seconds. Then there is imaginary part, yes, the imaginary part which is equal to 4 radians per second. Now, this is the frequency of oscillations. Now, what is the impulse response? Now, see here, the impulse response in time domain is, the impulse response in time domain is, the impulse response in time domain C of t, which is equal to some constant into e power real part. What is the real part? E power real part minus 2 into t, sine or cos. Sine or cos imaginary part is 4 into t, and the poles are repeated, and I am already saying that whenever the pole is repeated anywhere in the S-plane, we have one common term, that is nothing but t. T means repeated poles, right? Therefore, but if previous all the problems only 2 terms, but in this particular problem, forget about the constant, then there are 3 terms. Then first those 3 terms are make it to 2. So we already know that. Now this is the ramp. This is the combination of ramp signal. You know the combination of ramp signal. This is the ramp signal and exponentially decaying signal. Now, what is the combination of this ramp and exponential? This is the ramp signal and my exponential decaying. Multiplication is nothing but common area. This is the combination. Therefore, this is the combination of kt into e power minus 2t. Now, this combination is multiplied with sine 4t. Now, this combination multiplied with sine 4t, now the impulse response is, then I am already saying that, and I am already saying any signal multiplied with a sine, any signal, this is the signal now, any signal multiplied with a sine or cos, any signal multiplied with a sine or cos, what I am saying, forget about this sine or cos, then consider the other signal. Other signal is a combination of ramp and another signal is a combination of ramp and exponentially decaying. This is the ramp and exponential decaying, and mirror image, this is the mirror image. Now, in the common area, the frequency of oscillations. In the common area, the frequency of oscillations is in the common area, the frequency of oscillation. What is the frequency of oscillation? Now, this is the frequency of oscillation, which is equal to 4 radians per second. Now, this is the impulse response and in time domain directly. This is the impulse response in time domain directly. Some constant into t into e power minus 2t into sine 4t. This is directly, this is the answer. Okay. Now, based on that particular shortcut value, you can find for anything. See the real part, see the imaginary part. According to that, you consider one term, you neglect another term. If both are there, then you presented both the terms. Okay, if we repeat it, then you just add one extra term, that is nothing but t. Now this one, now you just solve. Now there are two poles, therefore order equal to 2, but the pole lies on the right hand side of its plane. System is unstable. If it is unstable, the time constant we cannot calculate. Time constant we cannot calculate. Now there is an imaginary part, therefore the frequency of oscillation is 5 radians per second. Now see here, the impulse response in time domain, when you write the answer directly, what is impulse response in time domain? Some constant into e power real part. What is the real part? E power real part is plus 3 into t, sine or cos, whatever it may be. What is imaginary part? Sine 5 into t. That's it. Then, but what is the response? I want to draw the response because the response drawing is important, because for matching you want to draw the response. Now forget about the sine and cos. Then other signal is exponentially increasing signal. Then mirror image. Mirror image. Now in the common area, mirror image. In the common area, the frequency of oscillation is, in the common area, the frequency of oscillation is 5 radians per second. In the common area, the frequency of oscillation is 5 radians per second. Now this is nothing but how the response is. Now the response is exponentially increasing. The response is exponentially increasing and increased amplitude of oscillation. The response is exponentially increasing and increased amplitude of oscillations. That's what, for any problem, for any poles location, then if you remember this shortcut method, then automatically you can easily solve for anything. But for drawing the responses also, you can see the procedure that such that you can easily understand. Okay, take this one also. Now see here. Now we will see the poles on the left hand side and we will see the poles on right hand side. Now we will see when the poles is on imaginary axis. Now See here. Now how many poles? 2 poles. Therefore, what is order? Order equal to 2. Order equal to 2. But when the poles is on imaginary axis, we don't know whether stable or unstable or whatever it may be. That we will see. Now what is the time constant? We have a time constant formula. Time constant is nothing but negative of reciprocal of real part. Is there any real part now? No, only imaginary part. Only imaginary part means real part is 0. When real part is 0, minus 1 by 0, therefore time constant is infinity because real part is 0. Only imaginary part means real part is 0. Therefore, what is the frequency of oscillation? The imaginary part, which is always gives the frequency of oscillation. Now, the imaginary part, which is nothing but 1. Therefore, this is 1 radians per second. Then, because this is the first time the pole is on imaginary axis. Then the pole is on imaginary axis. Then what happened? We will see. Now, whatever it may be, our answer is only one. Our question is only one thing. Our topic is the impulse response in time domain. Then, if it is an impulse response, we have some shortcut method. Use that one directly. Some constant into e power real part. Is there any real part? No, real part is 0. E power 0 means this is 1 into sine or cos, whatever may be. Imaginary part. What is imaginary part? Into 1 into t. Therefore, the impulse response in time domain, which is nothing but c of t, which is equal to k into e power 0 is 1, sine imaginary part is 1 into t. Therefore, now k, which is the peak amplitude of the signal, then you just draw the response. The impulse response in time domain is, now k is the peak amplitude. K is the peak amplitude. Minimum amplitude is minus k. Peak amplitude is plus k. Minimum amplitude is minus k. Peak to peak amplitude is 2k. K is peak amplitude is plus k. Minimum amplitude is minus k. Peak to peak amplitude is 2k. And the frequency of oscillation is, 1 radians per second. And the frequency of oscillation is 1 radians per second. And the frequency of oscillation is 1 radians per second. Now see the response. Now if you see this response, then now in previously, if the system is stable, the response is follows the input. If the system is unstable, the response does not follows the input. But what happened here? Even if you are giving the inputs on the time axis, if you give the inputs on the time axis, the response does not follow the input and does not away from the input. The response is maintained constant amplitude and frequency of oscillations irrespective of the input from minus infinity to plus infinity. Then that system is said to be marginally stable system. That response is to be a marginally stable response. Then this particular systems are called as marginally stable system. Marginally stable response. What is a marginally stable response? Now what is a marginally stable system? Now this is the marginally stable system. If it is a marginally stable system, where is the pole's location? The pole's location is on imaginary axis. If the pole is on imaginary axis, system is marginally stable. Then you take this one, then we will have some important points on this particular topic. Now in our sessions, we just take the two definitions. When the control system is said to be stable, when the control system is said to be unstable. Now I want to take here control system is to be marginally stable. When the control system is to be marginally stable. Now see here, the first point. Any control system response maintained constant amplitude and frequency of oscillations. Any control system response maintain constant amplitude and frequency of oscillations irrespective of inputs. Any control system response maintain constant amplitude and frequency of oscillations irrespective of input, then that system is said to be a marginally stable system. Any control system response maintain constant amplitude and frequency of oscillations from minus infinity to plus infinity. See here, this is from minus infinity to plus infinity, or from only positive side also not a problem, or from 0 to infinity irrespective of input. Now, any control system response maintain constant amplitude and frequency of oscillations from minus infinity to plus infinity or from 0 to infinity irrespective of input, then that system is said to be marginally stable system. Any control system response maintained constant amplitude and frequency of oscillations. Now, the second point is, if the control system is to be marginally stable, the poles lies on imaginary axis which are not repeated. Here is one point I am raising. The poles lies on imaginary axis, don't say marginally stable. The poles lies on imaginary axis which are not repeated, then only it is a marginally stable. If it is not repeated, when it is lies on imaginary axis not repeated, then only the system time constant is infinity. Now see here. Now here I am writing the poles lies on imaginary axis which are not repeated, then only the system is marginally stable. Sir, if the poles lies on imaginary axis which are repeated, what happen? That we also will see. If the poles lies on imaginary axis which are repeated, then we will see what happen. That possibility also we will now discuss. Now see, now the same question we are taking here, but now the poles are repeated. Now if the poles are repeated, then first we want to find these parameters. Now which means that there are 1, 2, 3, 4 poles, therefore order which is equal to 4. Then system is stable or unstable, that we will see later. Time constant also LT, but the only imaginary part, therefore the frequency of oscillation which is equal to 1 radians per second. Therefore now what is impulse response in time domain directly? The impulse response in time domain directly, C of t, which is equal to some constant into, there is no real part, therefore there is no E term, therefore only sine or cos, imaginary part is sine 1 into t, and the poles are repeated. The poles are repeated on the imaginary axis. Anywhere it is repeated, there is a t term. Therefore, now this is the impulse response when the poles on the imaginary axis which are repeated. Now what is the response? Then if you draw the response, now see here the response. With respect to time, forget about the sine term. Now this is the ramp, linearly varying. Then mirror image. Now in the common area, the frequency of oscillations. In the common area, the frequency of oscillations. What is the frequency of oscillations? 1 radians per second. In the common area, the frequency of oscillation is 1 radians per second. In the common area, the frequency of oscillation which is 1 radians per second. But now what is this? Then see the response. Now I am giving the inputs on time axis. The response does not follow the input and it is moving towards the infinity side. I am giving bounded input, but it will produce the unbounded output. Therefore system is, this is an unstable system. This is an unstable response. This is the unstable response, which means now you take the third point. Now see here, there is a correction in this particular second point. What is the second point? Now the poles, now see here, based on this particular point, then we'll take one important point. The poles lies on imaginary axis. The poles lies on imaginary axis which are, now which are we are taking, which are repeated, which are repeated. This is imaginary axis, but the poles are repeated. The poles are repeated on imaginary axis. If the poles lies on imaginary axis which are repeated, system is unstable. If it is unstable, we cannot find time constant. Time constant we cannot find. Therefore, this should be the 2 points you have to be remember. If the left hand side stable, right hand side unstable, but on imaginary axis don't blindly remember marginally stable. No, on the imaginary axis, if the poles are repeated, then only it is unstable. If the poles are not repeated, then it is marginally stable. We have to find the time constant. But if it is repeated on imaginary axis, so system is unstable, we cannot find the time constant, because for bounded input it will produce as the unbounded output. So previously we will write first you take this one. Therefore, now see here, so if the poles lies on imaginary axis, if the poles lies on imaginary axis, so 2 points we have to be considered. One point is marginally stable. Another point is unstable. When it is marginally stable, this is marginally stable, this is marginally stable, poles are not repeated. Now this is unstable, the poles are repeated. If poles are repeated, it is unstable. If the poles are not repeated, if it is marginally stable when the poles lies on imaginary axis. If the poles lies on imaginary axis which are not repeated, marginally stable, which are repeated, unstable. Now therefore, now you already have that when it is on the left hand side stable region, right hand side unstable region on imaginary axis, this is the situation. These are the poles location now for different locations in the S-plane, and this is the behavior of the system. And we will see in the next session the only one topic in the basics of the control system, how to find the transfer function, that we will see in the next session.